those is a note sheet. So if you go on there, if you go on to Google Classroom, you'll see two things. It'll say dividing polynomials, and then it'll say dividing polynomials warm-up. So right now, the warm-up looks like this. Okay? So you might not be able to see it very much, but this exact same thing is on Google Classroom. Oh, that's terrible. Okay, so it has kind of like a crossword puzzle type thing with, and if you can't see it, there is, that right there should be bold. So it's a division, taking you all the way back to elementary school. How do we divide? Don't let everybody speak at one time, it's okay. How do you divide two things? If you're going to divide two numbers, how do you divide? Grab your calculator and both things, right? What's that number right there called?
3,000.
No, not what it is. What's it called? Okay, so what's the one that's sitting outside?
Divisor.
Divisor. Okay, so you have a divisor and you have the dividend. Well, what's the quotient?
The answer.
So where does that go? Goes up here at the top. What's the remainder?
Like, what's that thing?
What's left over? Okay, well, those things we can answer. Now, question is, how? How do we divide? If I have 3,105, what goes in those first two blocks?
12.
Why 12?
Because 12 times 2 is 24.
Where'd you get 12 and 2?
So then 12 times 2.
Oh, put 12 in blank. Please. So, finishing. Oh, on the spot now.
Like that. That's like, okay. Wait. Yeah. That's it. So, you have 5. Wait, what? 96.
That's fine. 96. 9.
Sure.
It's 9.
This is the.
That's the remainder. So, how many times does 12 go into 3,105? 258 with a remainder of? 9. Now, typically we do what with that remainder? 9 over 12. Thank you. Now, this is one of those cases where we're talking about we can simplify down to 12. 9 over 12 would simplify down into what? 3/4. So, 12 goes into 3,105 258 times. 258 and 3/4 times. Okay? So, that's exactly what you're going to do. That is dividing two polynomials.
Wait, what?
That's dividing two polynomials. You just divided two polynomials. So you've already been doing dividing two polynomials. You've already been doing adding, subtracting, multiplying two polynomials. Why? What is 12? What kind of polynomial? A monomial. What about 3,105? It's a monomial. So when you divided these special case monomials way back in elementary school, you were dividing polynomials. You were just dividing special case polynomials. You're going to do the exact same thing today. I'm not going to change any rules on you. So how many of you guys can divide without your calculator? Let's go down. Okay, we'll find out. And this again is another reason that we need to be confident without our calculator. So I also posted up there this on your Google Classroom. Okay. So, not that, that's for my work. There it is. No, not you. All right, so a little bit of review. You're building a bin to hold some mulch for your garden. Bin's going to hold 162 cubic feet of mulch. The dimensions of your bin are x feet by 5x minus 6 feet by 5x minus 9 feet. That's all the bin. Think about it before you try to answer. And before you say anything, yes, you can give a numerical answer to this.
X times 5x minus 6 times 5x minus 6 equals to 162.
You see? While you're working on that, I'm going to take attendance. We got it? Hopefully. And this, like I said, this is on Google Classroom, so if you're trying to figure it out. Sorry. Okay. Sure. We got this thing yet? How tall is the bin? Get some crazy answers? Well, maybe more importantly than how tall is it, how do we figure it out? Well, if it's going to hold 162 cubic feet. Volume. Volume of what?
The thing.
What kind of bin is it? It's a cuboid. It's a rectangular prism. Okay, or a prism of some sort. Okay, in this case, we can assume it's a rectangular prism. So we have oh, terrible. Wait. Okay, so we have something here. Now, obviously, it's not going to have a top. Okay, we're not. It's a bin. Most bins don't have a top. It's going to have a lid. So, how long is this? X? Fine. If that's X, what's that?
X, 5x.
5X minus 6? Then what's that? 5X minus 9? Okay. Could it have been any other way?
Yes.
Sure. We could say that this is 5X minus 6, this is X, and this is still 5X minus 9. Or we could switch interchange any of these three. Okay? But typically, when it's written like this, it is length times width times height. Okay? The last one is typically your height. So we're looking for that 5X minus 9. How? Well, if the volume is length times width times height, what's my length? What's my width? What's my height? So what do I have to do? Multiply. So if I get X times 5X minus 6 times 5X minus 9, if I multiply all that, what do I get? What should I come up to? 162 cubic feet. Okay? So, can I multiply that one time? No, I can only multiply two things at a time. So take the first two and multiply. 5X squared minus 6X. Get a binomial. And that's minus 9. 162. Now what? Foil it out, and we get 45x squared, sorry, 30x squared, and 54x. It's still equal to 162.
Combine the like.
Combine like terms, okay? Any x cubed? No. 25x cubed. Negative 45x squared, negative 30x squared. I can put those together and get negative 75x squared plus 54x. What do I do after that? Well, bring this guy over. Minus 162 is equal to 0. Why do I do that? Because I'm trying to do what?
Group them.
Why group them?
So that you can find them.
So what am I doing?
Factoring.
To do what?
Find the
Find
zeros.
the x.
To find the zeros, to solve, to find the roots of this thing. I'm trying to find the values of this. Now, I have a 1, 2, 3, 4 term polynomial. How do I factor a 4-term polynomial? I've already said. What process have we talked about that I can factor this in? Factor by grouping. Do the first two things have anything in common?
5x squared.
25x squared, actually. So we have 25x squared. When I factor 25x squared out of 25x cubed, what's left? X minus 3. Okay. What about 54x and 162? 54. Does 54 go into 162? 3 times? Let's hope so. Then that means we have x minus 3 is equal to 0. Well, I got a common term, so factor that guy out. 25x squared plus 54 is equal to 0. Now I got two things multiplied to give me 0. What do I do? So set them both equal to 0. So now I have x minus 3 equals 0 and 25x squared plus 54 equals 0. Well, the one on the left is pretty simple. That was 3. What about the one on the right? Well, what happens? There's nothing. Gotta be square root of 54?
Yeah, wait.
What happens when you move 54 over? It's negative. So we get 25x squared is equal to negative 54. Divided by 25, okay. X squared is equal to negative 54 divided by 25. Square root of it. So x is equal to plus or minus the square root of negative 54 over 25. That's a lot of work for something that's very unnecessary. Why? Because I can't have a square root of a negative. What kind of number am I going to get here? Imaginary. So, doesn't work in this real sense. Now, we can get values, but since we're dealing with an actual bin that we are going to build, can I build this bin so that I deal with negative, or excuse me, imaginary numbers? No. So there's no need in even working about that. So x is equal to what? 3. Well, how tall is this thing then?
6 feet.
How'd you get that? 5 times 3 minus 9. 5 times 3 is 15. 15 minus 9 is 6. So this thing is 6 feet tall. Okay? So, applications. SAT style question. Yes?
But then you continue to 5x minus 6 with that height?
Sure.
Would I get the same height?
No. That's like you said at the beginning. Depending on where you put these, it's going to depend on what your height is. Again, that last value, length, width, height, the last one in this cuboid, the dimensions of a cuboid, is traditionally the height. Now, so you could have acceptable, it could have had 6. It could have had a height of what? 3 or 9. So it could have been an acceptable height of 3, 6, or 9, depending on the orientation of your cube. Okay? Good question. All right. Now, questions on what we did the other day? Yeah. Outside of synthetic substitution. And the only reason that I go outside of synthetic substitution is because we're going to do that again today. So we're just going to get more practice on it. So in other words, do you have any questions on whether something is or is not a polynomial or direct substitution? Hopefully not. Okay? All right. Yes?
27.
Which says what?
X to the power of 4 plus 5x squared plus 6.
Oh, factor. Okay. All right. So we have x to the power of 4. What was the other part?
Plus 5x squared
Plus 5x squared plus
6.
6. What's your question? How do you factor? Do I have anything that I can factor a 4th power? Is that one of my special terms? Special products? No. Are there 4 terms so I can factor my group? No. So the only thing that I really have to factor this thing is looking at a perfect square trinomial. Is this thing a perfect square trinomial? Give you a little heads up intro into further advanced calculus. Let A be x squared. Well, if a is x squared, substitution, well, then that's a squared plus 5a plus 6. Can I factor that?
Yes.
Yeah. Leading coefficient of 1. What two numbers multiply to give me 6? Add together to give me 5. 3 and 2. A plus 3. A plus 2. Well, now you factored it. Just go back and put in your a. So a was x squared plus 3, x squared plus 2.
Sure.
If you don't like that, just change it. I didn't change the value of it when I substituted that in there. I just made it easier for me to look at. Instead of looking at fourth powers and squares, I look at squares and first power. There's nothing in my rules that say I can't do that. Now, could I leave that fourth power in and factor it? Sure. What do you multiply by itself to get a fourth power variable? X squared. So I could simply jump this and go right here. Well, the only thing I'm going to multiply by itself to get x to the fourth is going to be x squared. The only thing I can multiply by 6, multiply to get 6, add together to get 5, is still going to be 3 and 2. So there you go. So I don't have to do the substitution, but if you do, it does make it a little bit simpler. Any other ones? Yes. X to the power of 3 plus 6x squared minus 4x minus 24 equals 0. Perfect. It's a cube, right? Well, is there somewhere a difference of 2 cubes? No, absolutely not. Okay. Well, is it a perfect square trinomial? Well, it's not even a trinomial. And it's definitely not a square. So it doesn't follow math, but it does have 4 terms. So what do I do?
X squared.
Group it? Group it. What do these two things have in common?
X squared.
X squared, pull it out. What happens when I pull an x squared out of x cubed? X. What happens when I pull it out of 6x squared? Plus 6. What do these two things have in common? Negative 4. What happens when I pull that out? X plus 6. It's not going to be minus. I pulled out a negative, so when I pull out a negative, it's going to result in a positive left over. Well, now that's still equal to 0. Now, x squared minus 4 minus x plus 6 is equal to 0. I could factor this because that's a difference of 2 squares, but I don't have to. Simply because I have 2 things multiplied to give me 0. Okay? I could because it's very easy to factor that. But I have x squared minus 4 equals 0. X plus 6 equals 0. X equals negative 6. X is equal to, it's not 2.
It's minus 2.
Because when I have that, it's x squared is equal to 4, and then when I take the square root, plus or minus the square root of 4, plus or minus 2. Reason being, if I go all the way back up here, how do I factor x squared minus 4?
X plus 2, x minus 2.
And that's still got to equal 0. Negative 2, positive 2. You've got to have both answers. Yes. 7d cubed or 7d cubed. Okay, 7d cubed.
Go ahead, 7t.
Equals 2z, 2d. D plus 5. Okay. All right. But we're going to solve this. First thing, distribute. 7d cubed, 2d squared. What happens when I multiply 2d and 5 halves? You get 5. 10d over 2 or just 5d. Now what? Bring all these things over, so I get 7d cubed minus 2d squared minus 5d is equal to 0. Problem is, this is not a sum of two cubes, it's not a difference of two cubes, it's not a perfect square trinomial, I don't have four things, I can't factor by grouping, but my common factor. What is my common factors throughout all three terms? D. Pull that guy out. So if I have D, whoops, not D equals. Factor that guy out, so I get 7d squared minus 2d minus 5 is equal to 0. Well, right away, I know that one possibility for d is what? 0. So now all I got to look at is 7d squared minus, whoops, not 5d, 2d. Minus 5 is equal to 0. Well, now what kind of thing am I looking at here? Quadratic. Oh, we're never going to get away from those. Okay? And that's the honest truth. You're never going to get away from a quadratic. Quadratic and linear functions are always going to be there. How do you solve a quadratic? We do the AC method. If that doesn't work, if it can't be factored, then I go back to my quadratic formula. Okay? Can this thing be factored? 7 times negative 5. 35. Negative 35. Are there two numbers that multiply to give me negative 35? Add together with positive 2. Don't think too hard on this. 7 and negative 5. Okay? Which one do you want to group with the 7?
How about the 7?
Does it matter though? Could I group the 5 with the 7? Sure. So I go 7d squared minus 7d plus 5d minus 5 equals 0. Now I got a 4-term polynomial, which is where we first started with factoring by grouping. Put the two together, 7d, d minus 1. Put these two together, you get a 5. You pull out the 5, you get d minus 1. So now we have 7d minus 5 is equal to 0, and d minus 1 is equal to 0.
Plus.
7d plus 5, sorry.
5 and 7.
Okay, so we do this, d is equal to negative 5 sevenths, and d is equal to 1. So d is equal to negative 5 sevenths, 0, and 1.
Okay.
Is that okay that we have three values for this?
Yeah.
Yes, because our degree is 3. Remember, the most solutions that you can have is the highest degree of your polynomial. So if you have a third degree polynomial, how many solutions at most can you have?
3.
3. Does that mean I have to have 3? No, I can have 0, 1, 2, or 3, and actually you can't have 0. Okay, so your third power, you have to have at least 1. Yes?
Where did he go?
Well, the d didn't go anywhere, but if I have something times this is equal to 0, I know that d is going to be 0, or this is going to be 0. So I just did it, but there was really nothing to solve here. So it didn't go anywhere. We just didn't do anything with it at that point. Okay? Any others? Good stuff, good stuff. Okay, here we go. Let me save my eraser. This is terrible. Oh, man, that's too much. Gotta love this. Gotta love this. Okay. All right. Dividing polynomials. Oh, it's really hard. Super hard. Oh my gosh. It's really not. I told you, you did this stuff in elementary school. It can't be that hard. Okay? So, when you divide polynomials, you got two methods. One, old school. Two, new school. Old school, you leave it in just like you had always in the past, and you follow the exact same patterns as you did when you were in second, third, fourth, whatever grade. Okay? Do you need this? What are you trying to do? Oh, we're trying to do it. Okay? So just use the long division. Nothing changed. Exactly the same way that we did the 12 into, what is it, 3,105? Was that the problem this morning? Okay? Follow those same rules. Nothing changes. We good? Well, let's take a look at it. Now, before we take a look at it, it's a question. When you divide two numbers of polynomials, whichever way you want to think about it, what can happen? What can happen? What do you mean, hold? What does that mean? Yes. Sorry? Okay, the answer is going to be a polynomial. Okay. What else? I think you're trying to say this, just to, maybe not the right words. What happens when you divide two things? Come on, you guys know this. Stop playing with your computers. Pay attention for a second. You get a factor. What's a factor? A little bit more. A number, that is true. A factor is a number that goes into another number evenly. What does that mean, evenly? No remainder. So the possible outcomes are that we end up with a factor, or we end up with a remainder. Those are your two outcomes. You're either going to end up with a number that is a factor, or you're going to end up with a number that has a remainder. Well, guess what? There's two theorems. There's a factor theorem and a remainder theorem. Your remainder theorem. Well, if it's going to be a remainder, okay? So when there is a remainder, okay? When we have a remainder, when a polynomial is divided by a binomial, now this is the only case. When a polynomial is divided by a binomial, it has to be a binomial. The remainder is simply the function evaluated at the constant term. K is a constant here. Okay? So if K is a constant, so if that thing is a constant, then we get that. Okay? So keep that in mind. Now, does the remainder theorem work for this first problem? Does it work for this first problem? So does it work? No, not particularly. There is another theorem that works here, but not this remainder theorem. So I can't use that. It's a shame. Okay? Because what you did the other day with direct substitution or synthetic substitution is right there. All I gotta do is put that thing in there. Then it says when I evaluate my function, or my polynomial in this case, by that constant term, I get my remainder. Okay, so keep that in mind. But here we don't have this. I got to divide it long division. How do you divide by long division? Exactly the same way you did when you just dealt with single numbers, monomials. Well, write this thing out. Oh, which one goes on the outside? Second, y squared minus y plus 1. Then which one goes underneath?
I to the power.
Process of elimination. You already used one, the other one's got to go on the underneath, right? So, y to the fourth plus 2y squared minus y plus 5. Now, before you go too far, this is just like synthetic substitution. What should I do?
The last the 1.
Add a 0 for what? Add a 0 for my y cubed values. So back this thing up and add a 0 for my y cubed. Whoops, not y squared. I have y squared. 0y cubed. Now plus 2y squared minus y plus 5. Now I've got all of my terms. 4, 3, 2, 1, 0. Okay? Well, now think about it. you would take this number that was sitting on the outside, multiply it by some number so that it got this number. Well, that's exactly what you do now. What am I going to multiply y squared to get y to the fourth? Not 2. That's going to give me 2y squared.
Y squared.
Y squared. So, y squared goes on top. What goes underneath?
Y.
Well, exactly like we got the 24. We take this number and multiply it by y squared. What is y squared times y squared? Y to the fourth.
Y to negative y to the power cube, yeah. And y squared.
Oops, y squared. Now what do we do?
And now you
Just take it away. Wipe it away. Subtract it. This is where a lot of mistakes are made. Because you don't distribute negative. You got to subtract all the terms, not just that first one. So now, this negative is going to make that negative, that positive, that negative. So y to the fourth minus y to the fourth, because what happens? 0. Obviously, that's what we wanted. 0y cubed minus negative y cubed. Y to the third. 2y squared minus y squared.
y squared. Plus y squared.
Oops. Keep on the right cubes for squares and squares for cubes. Okay?
That thing drops.
What thing?
Plus y.
The whole thing. Just drop the whole thing.
Might as well.
Might as well. Okay? You didn't do that in the old school, or in elementary school. You only dropped that one value. But it doesn't matter. You can drop the whole value. You can drop the one value. Honestly, it doesn't matter. Okay? Well, now, I do the same thing. Y squared. What times y squared is going to give me y cubed?
Y.
Why? Because we said. So, y squared minus y plus 1 times y gives me what? I know it's so hard. What do you get when you multiply that trinomial times y?
Minus y squared plus 1.
Glad you followed along. Y cubed minus y squared plus y. What do I do with that trinomial now?
Subtract.
Subtract it. So subtract that guy.
0.
Y cubed minus y cubed. Better be 0 or we did something wrong. Y squared minus negative y squared. 2y squared. Negative y minus y.
Negative 1.
Negative 2y. Bring that guy down.
Wait, what do we do with the plus 1?
There's no plus 1.
No, first. Y squared minus.
What's y times 1?
Y cubed. Negative y squared. Y. Okay. Well now, 2y squared minus 2y plus 5. Same process. What do I multiply by? 2. 2. Well, what do we get?
2y squared
2y squared
minus 2y
minus 2y
Minus.
minus 2.
plus 2.
Yeah, 1.
Ah, I'm just writing down what you said. Subtract. Okay. 2y squared minus 2y squared. Yes. Negative 2y minus negative 2y. 2. 5 minus 2. What happens to that 3?
Remainder.
It's a remainder. How do I write that? Ah! Stab me in the eye, the twig. No, you don't write point. That's what you did only when you were dealing with numbers. Yes, that's what we did when we were dealing with monomials. We put a decimal point and we kept the division going. The problem is there going to be anything that I multiply y squared by to get 3? No. Okay, at least not easily. So no points instead of points, just a plus. Plus what?
3.
Not 1 over 3.
Why would
Remember back to your fraction. You had the remainder. What'd you do with that remainder? You put it over what you were dividing by. So you put your remainder over what you're dividing by. Is it?
I was kidding.
3 goes into 28. How many times?
Nice.
9. 27. Subtracted 1.
9.
9. 1 over plus 1 over 3. Well, what is 9 plus 1 over 3? All right, don't give me that 0.3. 9 1/3. No points. 9 1/3. That's it. So the exact same thing that you did here in elementary school is the exact same process that we're doing here. No different. The only thing is it looks different because instead of just having, well, I just want to have my single numbers to make it easy and stay in elementary school. Well, that's fine, but we're going to step it up a little bit. Big boys and girls. Got a big boy girl pants on. Okay? We're going to do big boy and girl divisions. Okay? So it's no different though. As soon as you tell yourself it's different and say it's hard and it's complicated and it's not the same, then you're going to have mistakes. But if you treat it just like this, which I know every single one of you can do, this becomes a piece of cake. Okay? It's very simple. Don't complicate it. Okay. Now, let's take a look at some other ones. Easy, schmeezy. So, here's one. Take x cubed minus x squared minus 2x plus 8, divide that by x minus 1, divided by x plus 2. Go for it. Oh, I know, we have to work. Oh, this issue's not working for us.
Is it the same way?
No, unless you know some magical different way. Unless you know how to do synthetic division. Do it the same way. Oh. Okay, so apparently the document on Google Classroom does not like my equations that I input, so I'll have to take that down and insert a PDF, which will be. So, I'm sorry. As a matter of fact, here, I'll do that while you're working on these. Google Classroom doesn't like the x cubed minus x squared plus, or minus 2x plus 8. It's not, is it on yours? Did you download it or just look at it? Oh, through Google Drive. Okay. Try to bring it to your Google Drive instead of if you just preview it. Sometimes it doesn't go. I forget about that sometimes. Sorry. The only reason that I keep it as a document is if you want to put your notes and stuff on this. Does everybody? Just a quick question. Does everybody on your PDF edit the PDF?
Yeah.
Okay, so if I put a PDF up there instead of the docs, it's okay? Yeah. Yes. If you know how, go for it. Oh, God.
This is so exciting.
Why are you? Why?
Your teacher?
That's me.
Can you check if I did this correct?
There it is.
So, like, it's.
Everything else is good, yes.
I got the answer.
What is it?
I have one right now.
I know I got it wrong, but I just want to.
Well, that's, if you know you got it wrong, why do you think you got it wrong? Let me see what you
Is it right? Oh. Negative.
No, like negative x squared minus negative x squared. So you said the second one, like doesn't have a.
So what do you know about it? What do you know about it? X plus 2, that's perfect. It's a what? If it doesn't have a factor, this is a what of this? Perfect. This one is a factor. Okay. All right. So, did we get the answer?
Yeah.
Should have. What happens when we divide x cubed minus x squared minus 2x plus 8 by x minus 1? What do we get?
X squared
Minus 2
plus X squared is the first term.
plus 6 over x.
This one we should have x minus 2 plus 6 over x minus 1.
X squared.
X squared, yeah.
X squared, sorry. X squared.
Why did 6?
Because 8 minus 2 is 6.
Is it 8 plus?
But then the first.
So then you guys subtract. Let's make sure.
It's negative.
Okay, so we have x minus 1 into x cubed minus x squared minus 2x plus 8.
Oh.
You get x squared. So that gives us x cubed minus x squared, but then I gotta subtract it. That actually cancels both those out, brings down to negative 2x plus 8. So that's gonna make negative 2x, excuse me, negative 2. So then we get negative 2x plus 2. You subtract it. 8 minus 2,
You get
6.
Right. Like I want to change the sign.
Change the sign. That's the hardest part about all this. Just like when you did in elementary school. You do this, but then you subtract each letter. Well, that's probably why you forgot to do it. All right. So what happens when you do this one?
what?
What is it?
What? X squared minus 3x plus 4.
X squared minus 3x plus 4. So if we come out to x squared minus 3x plus 4, did we have a remainder?
No.
No. So what do you know about x plus 2? It is a factor of x cubed minus x squared minus 2x plus 8. If it comes out to no remainder, it's a factor. Okay? Now, what good does that do? Well, if I'm solving this, you know that that's a factor. Well, if it's a factor and I'm solving it, then I know that x plus 2 times x squared minus 3x plus 4 is equal to 0. Because when we solve it, don't we set the polynomial equal to 0? Well, now if I'm solving it, I can factor this, I can solve this, and then I can either factor that or solve that quadratic, and I can find all of the zeros of this function.
Wait, wouldn't it equal x?
Sure it does. It equals x cubed minus x squared minus 2x plus 8, but if I'm solving that, that's equal to 0 as well. Now, if I know that that's a factor, I can factor this. Well, it's not too bad. This one, I know if I was going to solve it, I can put these two together, I can put these two together, factor by grouping. Okay, maybe. Or, if I know that that's a factor, this gives me this result, I can solve that result too to find the other solutions. Okay? What we're going to do next. So now what I can do is I can say, okay, given that x minus 2 is a factor of this polynomial, find the other zeros, or find all of the zeros of the function. Well, what's it mean to find the zeros? X when the y, when the return value is equal to 0. So when your original function is equal to 0. So now we can go through this and we can find all these results. Now, about this next thing, synthetic division. Well, synthetic division is the same as synthetic substitution. Okay? Now, in order to do synthetic division, you got to go back up to that rule that I gave you with the remainder theorem. It's a negative k. Right? With the binomial, it's a negative k. So what's my k here? K is what? K is negative 1. So what do I want my negative k to be? 1.
Ash comes up.
I hope you're paying attention or you're going to be completely lost.
I'll take it.
I doubt it. 1, negative 1, negative 2, and 8. How do I do my synthetic division? Well, same thing. 1, 1, 0, 0, negative 2, negative 2, and 6. Wasn't 6 our remainder? Yeah. This is the coefficient of my x squared term. This is the coefficient of my x term. This is my constant. That's my remainder. Okay? So we'll do it over here. If we have this, k is 2, so what is negative k? Negative 2. So if I go negative 2 into 1, negative 1, negative 2, and 8, 1, negative 2, negative 3, 6, positive 4, negative 8, and a result of 0. So now, x squared minus 3x plus 4. Isn't that what we got?
No, but Mr. Teacher, how do you know one variable?
What do you mean?
Like just by doing that?
How do I know what variables to use? Well, what am I going to multiply by 1? What x
Synthetic is
times 1 is going to give me x cubed? 1x squared. And then because in synthetic division, we go decreasing order, I know that in my synthetic division, this is x cubed, x squared, x to the first, and x to the 0. Then I know that when I do this, my result is going to be 1 less than the x cubed, which is going to be x squared, x x to the 0, and then the 0 is going to be my remainder. So that being said, do this division first by long division, and then by synthetic division. You should come out with the same answer. Okay? Because you're dividing the same binomial, excuse me, polynomial by the same binomial, so you should come up with the same answer.
She said she got it right, and I gave her questions. She got it right. I got it.
Okay.
So I was kidding, obviously. I like to know people arguing. So if I find two more right now, I'll get you one. This guy. Wednesday practice, Monday practice. What if they're the same grade? What if they don't know? That's fine, they can put something. If I get it, like, next one.
Is x plus 6 a factor of 2x squared plus x minus 7? No. How do you know? How do you know it's not a factor? It has a remainder. Excuse me, it has a remainder. Did you get that remainder by long division or synthetic division?
Yeah.
Well, hopefully both. Okay? Well, long division. So if we go x plus 6 into 2x squared plus 13x minus 7. What do I have to multiply x plus 6 by to get a 2x squared to begin with?
2x.
2x. So that goes up top, 2x. So then we get 2x squared, okay, plus 12x. Subtract that. What's left? Well, 2x squared minus 2x squared, 0. 13x minus 12x gives me not minus, just positive 1x. And then we got minus 7. Well, what do I multiply x by to get x? 1. So it goes in there 1 time. So that's x plus 6. Subtract that, and the result is going to be what? Negative 13. Okay, so then we get plus, or minus, plus negative 13 over x plus 6, or you could do minus 13 over x plus 6. So we get a remainder. Now, check that. Go to your synthetic division. What is my k?
Negative 6.
My k is 6, so I want my outside to be negative 6.
Yeah.
What are my coefficients in descending order? Are my variables or my terms in descending order? Are there any gaps? No. So I can write my coefficients as 2, 13, and negative 7. Now what? Bring my 2 down, multiply, combine, multiply, combine. And since I started with x squared, this term is going to be what?
X.
1 less than x squared, so that's going to be x plus 1 minus 13 over x plus 6. And you're done. And you get 2x plus 1 minus 13 over x plus 6. You get the exact same answer. We should get the same answer. We did the same operation. We just did the same operation in 2 different ways. Yeah. Because if we started with x squared, this is where you guys need to pay attention. We start with x squared. I do my division. It's always going to be 1 less than the power you started. Because if I start with x, when you did a monomial divided by a monomial, what happens when you take x squared and divide it by x? You decrease the exponent by 1. So if I start with x squared, when I decrease that exponent by 1, my result is just going to be x to the first, or just x. If I started with x to the fifth, and I decrease it by 1, then this is going to be a 4th power. Okay?
7 over 10 divided by 1 over 2. And how are the reciprocals?
All right.
7 over 10 divided by 1 over 2.
Now, factor theorem. So we talked about the remainder theorem, now the factor theorem. Factor theorem says that a polynomial f of x has a factor x minus k if. What's IFF mean? And no, I didn't spell if. Yes, seriously, I didn't spell if wrong. What does IFF mean?
If.
If.
IFF means if and only. Yes.
Whoa.
If IFF means if and only if. Now, so a polynomial f of x has a factor x minus k if and only if f of k is equal to 0. Well, that goes right back to the remainder theorem. If the remainder is 0, then you started with a factor. If you start with a factor, if you start and you do your division and your division comes out with no remainder, then you know that what you started dividing by is a factor of the polynomial. If you do your division and at the end you don't end up with a remainder, you know you started with a factor. Flip that around. If you know you're starting out with a factor, are you to end up with a remainder? Okay? If you know it's a factor, the remainder is going to be 0. If you know the remainder is 0, you know you got a factor. It's a two-way street. Okay? Now, I separated these because your book separates them. A lot of times it's put together as the remainder and factor theorem. Okay? But your book deals with them as separate, so I thought I'd separate them. But a lot of times, because you'll see them together, it's the remainder and factor theorem, because it works both ways. Okay? You start with a factor, you end up without a remainder. You start with knowing that you do your division and you end up without a remainder, you know you started with a factor. Okay? So now, what does that mean for you? After this, given that f of negative 6 is equal to 0, what does that tell me?
F of negative 6.
What does that tell you?
Negative 6 is
Negative 6
in the
gives me what?
0. No.
Gives me a 0. Is a factor. That means, am I going to have a remainder?
Yes.
No. So if I put that negative 6 in there, I can solve this. How? X plus 6 is a factor. So I have two choices. I can take x plus 6 and I can divide that into 3x cubed plus 14x squared minus 28x minus 24. Or I can do what? Use my synthetic division. Either way, you're going to get the rest of the factors. How am I going to get the rest of the factors? Because it tells me that when x is negative 6, I get 0. Well, that's a factor. Remember, a factor means that I have two things that multiply to give me 0 if that result is 0. And if one of them is negative 6, that means that x plus 6 times whatever this is gives me a result of 0. I don't know what this piece is yet. But I know if I have x plus 6 and it gives me a result of 0, x plus 6.
Minus will be the answer lab of the division.
Sorry, what? Yes, this case will be whatever it is up here, yes. Okay? Because this times this gives me a result of this if this guy is a factor. Well now, how does that help me? I know that this goes here, or I could negative 6 into 3, 14, negative 28, negative 24. Do your synthetic substitution / synthetic division. It's the same thing. Okay? Either one that you do, you will get the result back. What does that allow you to do? I hope you're paying attention to this. Once I do this, I find that other factor. What does that allow me to do? I can find the other factors, and I can also do what? Find the other zeros. Okay? So, your homework is not much. It's to finish the problems that we started, including these word problems.
Thank you.
What's it say on the bottom? It says on the bottom that you have some extra. That's up to you. I'm not looking for those. I'm looking for the ones that are on the sheet. Yep.
What's up?